Exercise 710. Evaluate the integrals in exercises 1 to 8 using substitution.
First question, integral 0 to 1 x divided by x square plus 1 dx. This is a very simple question. We have x square term in the denominator and x dx in the numerator. We will substitute x square plus 1 as t, differentiate both sides. 2x dx is dt. Therefore, x dx is dt divided by 2. Now let us find the limits. When x is 0, these are the values given for x variable. We are going to change the variable to t. So corresponding t values should be written. So when x is 0, let us substitute here and find the corresponding value of t. So t will be 0 square plus 1, which is 1. Similarly, when x is 1, substitute x as 1 here. 1 square plus 1, t becomes 2. Now let us change the variable to t. Limits also should be written for t. Integral 1 to 2, x dx is dt divided by 2 and the denominator is t. No more x. Everywhere it will be t. Even the limits are, the corresponding values of t should be written. Now let us integrate. Integral of 1 by t is log of absolute value of t and the limits are 1 to 2. Apply the upper limit first minus the lower limit. Log 1 is 0. Therefore, the answer is half into log 2. Question 2. Integral 0 to pi by 2 root of sine phi into cos power phi d phi. Here the variable is phi. Don't change the variable. Do the sum with the same variable. We have odd power for cos function. Let us split this odd power. Integral 0 to pi by 2 root of sine phi. Cos power phi can be written as cos power 4 phi into cos phi d phi. Now since we have cos phi d phi, let us change rest of the function in terms of sine. So let us write this in terms of sine. I can write this as integral 0 to pi by 2 root of sine phi cos square the whole square into cos phi d phi. Integral 0 to pi by 2 root of sine phi. Now we are going to use the identity. Cos square phi is 1 minus sine square phi. Remember, in splitting the odd power method, we use sine square plus cos square equal to 1 identity. We have cos phi d phi and the rest of the function is in terms of sine. Let us substitute sine phi as t. Differentiate both sides. Cos phi d phi is dt. Now corresponding t values we have to substitute. So when phi is 0, the limits given are for phi. Let us find the corresponding t values by substituting it here. Sine 0 is 0, so t becomes 0. When phi is pi by 2, t becomes sine pi by 2, which is 1. Therefore, the corresponding limits for t variable are 0 and 1. It becomes root t 1 minus t square the whole square and cos phi d phi becomes dt. Root t is t power half. Let us expand this using a minus b the whole square formula. A square plus b square minus 2ab term. times dt. Let us open the brackets. T raised to half plus t raised to 4 plus half. 9 by 2 minus 2 times t square into t power half, 2 plus half, which is 5 by 2 times dt. Each term can be integrated easily using x power n plus 1 by n plus 1 formula. Integral of t power half will be t power half plus 1, which is 3 by 2, divided by 3 by 2. I am writing the reciprocal. It becomes into 2 by 3. And the limits are 0 to 1 plus t power 9 by 2 plus 1, which is 11 by 2 divided by 11 by 2, which is 2 by 11. Let us write the limits. Minus 2 times t power 5 by 2 plus 1 is 7 by 2 into 2 by 7, and the limits are 0 to 1. We can separately apply the limits if you have addition or subtraction in between the terms. 2 by 3 times upper limit is 1 power any number is 1 and the lower limit is 0. Here also upper limit is 1, lower limit is 0. Minus 4 by 7 times 1 minus 0. 2 divided by 3 plus 2 divided by 11 minus 4 divided by 7. Let's take LCM. The LCM is 3 times 11 times 7. 77 times 2, which is 154, plus 21 times 2, 42, minus 4 times 33, which is 132. 196 minus 132 divided by 33 times 7, which is 231. Subtract and write. 64 divided by 231 is the answer. Question number 3. Integral 0 to 1 sine inverse of 2x divided by 1 plus x square dx. We have a direct formula for this. Sine inverse of 2x divided by 1 plus x square is 2 tan inverse of x.
Or if you want to use substitution method, then you have to substitute x as tan theta. But we will use this formula method.
Therefore, the integral becomes integral 0 to 1 of 2 tan inverse of x dx. We know that we don't have direct integration formulae for inverse trigonometric functions. So we have to use integration by parts method by taking 1 into tan inverse of x. 1 is an algebraic function and tan inverse is inverse trigonometric function. So I comes first in islate. This is our first function and this is the second function. Let us use by parts formula. Integral of first function into second function dx is first function into integral of the second function minus integral differential of the first function into integral of the second function dx. 2 times first function is tan inverse of x into integral of second function. Integral of 1 is x minus integral differential of the first function. Differential of tan inverse of x is 1 divided by 1 plus x square times integral of the second function dx. And the limits are 0 to 1. We can write the limits for the first term also, 0 to 1. Let us apply the limits for the first term. Tan inverse of 1. Tan inverse of 1 is pi by 4 into 1 minus lower limit is 0. X is there, x is 0, so 0 into anything is 0, minus this integral has to be done by substitution because we have x square term in the denominator and x dx in the numerator. Let us use substitution. We will take 1 plus x square as t. Differentiate both sides, and x dx is dt divided by 2. We have to change the limits. So when x is 0, substitute the values of x here and find the corresponding values of t. When x is 0, t is 1. And when x is 1, t is 1 plus 1 square, which is 2. Let us write the corresponding limits for t variable. The limits are 1 to 2. Numerator is x dx, which becomes dt divided by 2. Half is a constant, that's why I have written outside the integral. Divided by the denominator becomes t. 2 times pi by 4 minus half into integral of 1 by t is log of absolute value of t, and the limits are 1 to 2. Let us substitute the limits. Pi by 4 minus half into log 2 minus log 1. We know that log 1 is 0. Therefore, it becomes 2 times pi by 4 minus half log 2. Let us open the brackets. The answer is pi by 2 minus log 2. Question number 4. Integral 0 to 2x times root of x plus 2 dx. We are not able to distribute this because of the root sign. So we can easily get rid of the root sign by substituting root of x plus 2 as t. Let us square both sides to remove the root sign and differentiate both sides. Let us calculate the corresponding limits for t variable. When x is 0, t will be, let us substitute here, t will be root of 0 plus 2, which is root 2. And when x is 2, 2 plus 2, 4. So t becomes root of 4, which is 2. Now let us change the variable and the corresponding limits. So the limits for t will be root 2 to 2. We have to substitute for the variable x. We can get x from this. From this step, x is t square minus 2. So we get t square minus 2. And root of x plus 2 is t. And dx is 2t dt. Let us open the brackets and write integral root 2 to 2 of, I can take 2 out, and here we have t square. Let us multiply by t square. So it becomes t power 4 minus 2t square times dt. Now this function is very simple to integrate. 2 times t raised to 5 by 5, and the limits are root 2 to 2 minus 2 is a constant. Integral of t square is t cube divided by 3, and apply the limits for the variable term. 2 times 1 by 5 into 2 raised to 5 minus root 2 power 5 minus 2 by 3 times 2 cube minus root 2 cube. We get 2 times 1 by 5 multiplied with 32 minus root 2 power 5 is 4 root 2 minus 2 by 3 times 2 cube is 8 root 2 cube. Root 2 into root 2 is 2 root 2. We get 32 divided by 5. and 4 by 5 times root 2 minus 16 by root 3, minus into minus is plus, 4 by 3 times root 2. We can take 15 as the LCM. It becomes 32 times 3, which is 96, minus 3 fours are 12 root 2, 5 times 16, which is 80, and plus 5 fours are 20 root 2. The answer becomes 96 minus 80 is 16, and 20 root 2 minus 12 root 2 is plus 8 root 2 divided by 15. We can take 8 out, so it becomes 16 times 2 plus root 2 divided by 15. You may take one root 2 also out. So 16 root 2 times root 2 plus 1 divided by 15 is the answer. Question number 5. Integral 0 to pi by 2 sin x divided by 1 plus cos square x dx. This is a simple question. We have cos function in the denominator and its differentiation sin x dx is in the numerator. Let us substitute cos x as t. Differential of cos x is minus sin x dx equal to dt. Let us change the limits. When x is 0, t will be, substitute here, cos 0, which is 1. And when the x limit is pi by 2, the corresponding t limit will be cos 90. Cos 90 is 0. Now we have to write the corresponding t limits. The limits are 1 to 0. Don't interchange and write. Lower limit is 1, upper limit is 0. Now sin x dx becomes minus dt divided by 1 plus t square. You may take minus sign out and write the integral of 1 by 1 plus t square, which is tan inverse of x. Or you may write cot inverse also. Minus the integral is tan inverse of t, and the limits are 1 to 0. Upper limit is tan inverse of 0 minus lower limit is tan inverse of 1. Tan inverse of 0 is 0 and tan inverse of 1 is pi by 4. Minus of minus plus pi by 4 is the answer. Question number 6. Integral 0 to 2 dx divided by x plus 4 minus x square. We have a quadratic function and numerator is 1. And we know that if we have a constant in the numerator and a quadratic expression in the denominator, we complete the squares. Or if you are able to factorize, you can use partial fraction method also. We will use completion of squares method. I am taking minus sign out from the denominator. So it becomes minus of x square minus x minus 4. Integral 0 to 2 of, minus sign has been taken out, dx divided by x minus, divide the coefficient of x by 2, which is half, complete the squares, subtract b square term, which is half square, 1 by 4, and the constant term is minus 4. Or you may add plus 1 by 4 minus 1 by 4 and complete the squares. But this method is applicable for all questions. That too, if the coefficient of x square is 1, completion of squares is easy. Just you have to divide the coefficient of x by 2. That will be your b term. Minus of integral 0 to 2 dx divided by x minus half the whole square. Let us simplify this. Minus 1 by 4 minus 4, the LCM is 4. it becomes minus 17 divided by 4, which can be written as minus root 17 by 2 the whole square. Now we will use 1 by x square minus a square formula, which is 1 by 2a log of x minus a divided by x plus a and plus c. But for definite integral questions, we won't be writing plus c. 1 by 2 times a. A is root 17 divided by 2 log of absolute value of x, here is x minus half, minus a, which is root 17 by 2, divided by x minus half plus root 17 divided by 2. And the limits are 0 to 2, which is minus 1 by root 17 log of, let us take LCM and simplify this expression. We get 2x minus 1 minus root 17 divided by 2x minus 1 plus root 17. And the limits are 0 to 2. Let us substitute the limits. Minus 1 by root 17 times upper limit is 2. So log of 2 2s are 4, 4 minus 1 3. 3 minus root 17 divided by 4 minus 1 3 plus root 17 minus, now the lower limit is minus 1 minus root 17 divided by minus 1 plus root 17. Log of 3 minus root 17 by 3 plus root 17 minus log of, let us cancel negative sign here, 1 plus root 17 by 1 minus root 17 minus 1 by root 17. Log a minus log b is log a by b. Log of 3 root 17 divided by 3 plus root 17. We will write the reciprocal of this because it is division here. So 1 minus root 17 divided by 1 plus root 17, which is minus 1 by root 17 times, let us multiply and write, log of 3 minus 3 root 17 minus root 17 plus 17 divided by 3 plus 3 root 17 plus root 17 and plus 17 minus 1 by root 17 times log of, let us add the like terms, 20 minus 4 root 17 divided by 20 plus 4 root 17 and cancel 4 minus 1 by root 17 log of 5 minus root 17 divided by 5 plus root 17. Let's rationalize the denominator. The rationalizing factor is 5 minus root 17. Minus 1 by root 17 log of 5 minus root 17 the whole square. And the denominator is of the form a plus b times a minus b, which is a square minus b square. Minus 1 by root 17 log of a minus b the whole square is a square plus b square minus 2ab divided by 25 minus 17. We get minus 1 by root 17 times log of 25 plus 17 is 42 minus 10 root 17 divided by 25 minus 17 is 8. Minus 1 by root 17 log of cancel 2, 21 minus 5 root 17 divided by 4. This is the answer with minus sign outside. If you have taken minus sign inside and used the formula, you would have got a different answer. Your answer would have been with plus sign in the numerator. Or you can get this answer, 1 by root 17 log of absolute value of 21 plus 5 root 17 divided by 4. That is, by taking minus inside the function, you could have used 1 by a square minus x square formula. So in that case, your answer would have been this. Question number 7. Integral minus 1 to 1 dx divided by x square plus 2x plus 5. Numerator is a constant and denominator has a quadratic term. We will use completion of squares. Or if you are able to factorize, you may use partial fraction, but here factorization is not possible. We are going to complete the squares. Integral minus 1 to 1 dx divided by x square term coefficient is 1. So completion of squares is easy. A term is x plus divide the coefficient of x by 2, which is 1, and complete the squares. Subtract b square term and add the constant term which is given. Integral minus 1 to 1 dx divided by x plus 1 the whole square plus 4. Plus 4 can be written as 2 square. Now we will use 1 by x square plus a square dx formula, which is 1 by a tan inverse of x divided by a plus c. 1 by a is 2 here. Tan inverse of x term is x plus 1 divided by 2. And the limits should be applied along with the function. Half into tan inverse of upper limit is 1 plus 1, 2. 2 divided by 2 is 1 minus the lower limit. Tan inverse of minus 1 plus 1 becomes 0. Tan inverse of 1 is pi by 4 and tan inverse of 0 is 0. The answer is pi divided by 8. Question number 8. Integral 1 to 2 1 by x minus 1 by 2x square times e power 2x dx. Integral f of x plus f dashed of x times e power x dx will become f of x e power x. But this formula is applicable when you have e power x term. Look at the coefficient of x, it is 1. But here we have 2x. So let us use substitution, 2x as t. So 2 times dx is dt. Dx is dt divided by 2. Let us change the limits. If x is 1, t becomes 2. And if x is 2, t becomes 4. So the limits are 2 to 4. 1 by x is 1 divided by x is t by 2. So it becomes 2 by t minus 1 by 2 times x square. From this, x square is t square by 4. And this is e power t. Dx is dt divided by 2. Let us remove half out. Integral 2 to 4. We can take 2 out. it becomes 1 by t minus 1 by t square e power t dt. Now we can apply that formula. This is our f function and this is f dashed, because differential of 1 by t is minus 1 by t square. And look at the coefficient of e power t. T has the coefficient 1. Now the formula is applicable. It becomes f of x, which is 1 by t and e power t. The limits are 2 to 4. 1 by 4 e power 4 minus 1 by 2 e square. 4 is the LCM. E raised to 4 minus 2e square. The answer is e square is common. We get e square minus 2 and divided by 4.
The other method to do this question is without using substitution, which is easier.
We will write this into two integrals. I am distributing it. Let us do integration by parts for the first integral. So this is the second function and 1 by x is the first function. First function into integral of the second. Integral of e power 2x is e power 2x divided by 2 minus integral differential of the first function. 1 by x can be written as x power minus 1. So differentiation is minus 1 x raised to minus 2. So differential of the first function is minus 1 divided by x square. And integral of the second function is e raised to 2x divided by 2 times dx. We have to write the limits. The limits are 1 to 2 and here also 1 to 2, and copy the last term. These two terms are getting cancelled because this becomes plus, minus into minus, and here it is minus. Same terms with positive and negative signs. So apply the limits here. Upper limit is 1 by 2 e power 4 divided by 2 minus the lower limit e square divided by 2. Take e square by 4 common. We get e square minus 2. Question number 9. Integral 1 by 3 to 1 x minus x cube whole raised to 1 by 3 divided by x power 4 dx. Integral 1 by 3 to 1. We will remove x cube from the numerator. We will get 1 by x square minus 1. And the power 1 by 3 is for the whole thing, including for x cube, divided by x power 4 dx. Integral 1 by 3 to 1. Let us distribute this power 1 by 3 to both the terms. X cube power 1 by 3 becomes x, and this will be 1 by x square minus 1 whole raised to 1 by 3 divided by x power 4 dx. We can cancel one x here. Therefore, we get integral 1 by 3 to 1. 1 divided by x square minus 1 whole raised to 1 by 3, and denominator becomes x cube. Let us substitute 1 by x square minus 1 as t. 1 by x square can be written as x power minus 2. Let us differentiate. It becomes minus 2 x raised to minus 3 dx, which is minus 2 divided by x cube dx is dt. and we will change the limits. When x is 1 by 3, t will be, we have to substitute it here, 1 divided by 1 by 9 will become 9, 9 minus 1 is 8. And when x is 1, 1 by 1, 1 minus 1, t becomes 0. The lower limit is 8, the upper limit is 0. And the numerator is t raised to 1 by 3. And dx by x cube. We have dx by x cube in the function, which becomes dt divided by minus 2. Minus 2 is a constant.
Let us take it out. Minus 1 by 2.
Let's integrate t power 1 by 3. T raised to 1 by 3 plus 1 will become 4 by 3. Divided by 4 by 3 will become 3 by 4. And the limits are 8 to 0. Minus 3 by 8 times. Upper limit is 0. Lower limit is 8 raised to 4 by 3. Minus 3 by 8 times. 8 power 1 by 3 is 2. 2 power 4. Minus into minus is plus. 3 by 8 times 16. The answer is 6. The correct option is A. Question number 10. F of x is equal to integral 0 to x t sine t dt. And we have to find f dashed of x. After integration, if we substitute the limits, the answer will be in terms of x. And we have to differentiate. So integration and differentiation will get cancelled. The answer is going to be x sine x. We know that the answer will be x sine x, but we will do by parts method. Let us take the first function as t is an algebraic function, sine t is a trigonometric function, a comes first, t is the first function, sine t is the second function. Integration by parts, first function into integral of the second function. Integral of sine t is minus cos t minus integral. Differential of the first function is 1. Integral of sine t is minus cos t, so it becomes plus here. Cos t dt. Let us write the limits for the first term also. Substitute the limits for the first term. So x cos x minus 0. And here integral of cos t is sine t. And the limits are 0 to x. We get minus x cos x and plus sine x. Sine 0 is 0. This is our f of x. We have to find f dashed of x. We will use product rule to differentiate this. Minus of u dash v plus u v dash. Differential of cos x is minus sine x. And plus differential of sine x is cos x. Minus cos x plus x sine x and plus cos x. Therefore, the final answer is x times sine x. And the correct option is B.